Okay, so today we're going to talk about linear and nonlinear rates of change. So you can see that our essential question is how can you identify linear and nonlinear rates of change and the functions they're associated with. So if you remember, we talked about rate of change the other day when we were comparing linear and exponential functions, and that the rate of change is actually a ratio that compares the amount of change in the dependent variable to the amount of change in the independent variable. So it's always going to be the change in the dependent, which is y, over the change in the independent variable, which is x. So hopefully that reminds you of the formula for slope of y2 minus y1 over x2 minus x1. So you're trying to figure out the rate of change by basically calculating a slope. All right, so let's look at this example. It says the table shows the price of 1 ounce of gold in 2005 and in 2008. So you can see here, in 2005, 1 ounce was $513 per ounce, and in 2008, it was $870 per ounce. So again, to find the rate of change, you can calculate the change in y, which is 870 minus 513, over the change in x. And when you calculate that, you get 119 per year. So if I was going to write a linear function, I could say that the slope of the linear function is $119 per year. All right, so again, here's an example. Determine whether each function has a constant or variable rate of change. So constant is going to be when it has a slope. So every time it has a constant change. It's going up or down by the same thing every time. Whereas the variable rate of change means just like it looks. Variable, it's going to be changing a lot. It's not going to be the same every time. So here we have these points right here put into the table. And so right here you can see it's going up by 1, 2, 3, 2. And then here it's up by 4, up by 4, up by 0, up by -2. So I can't really just go by this because remember, if I'm going to check the y's, the x's have to have a constant change, but the x's do not have a constant change, so I'm going to have to actually go ahead and check. So over here, I can see that the rate of change for the first part, if I do 4 minus 0, that gives me 4, and 1 minus 0, that gives me 1. So 4 over 1, I have a rate of change of 4. If I look at the second part, I do the change here, so 8 minus 4 gives me 4, which is where this blue numerator came from. And then 3 minus 1 is 2. So see right here, they did the changes. It's like 4 over 2. That's a change of 2. Then 0 over 3, that's a change of 0. At that point, I can see that it's going to be a variable rate of change because it has a change of 4, then 2, then 0. So that is not going to make a linear function. Okay, let's try these. So we found from the x's it went up by 1, up by 3, up by 2, up by 1. And then the y's, you can see the changes over here. So what you're going to do is do the change in y over the change in x. So 1 over 1 was a change of 1. 3 over 3 was a change of 1. 2 over 2 was a change of 1. And 1 over 1 is a change of 1. So therefore, this one has a constant rate of change. Okay, so I want you to go ahead and pause the video and determine whether each of these functions has a constant or a variable rate of change. Okay, so hopefully you tried those on your own. So I have the first example written out here. Sorry, I have no mouse, so this is the best I can do. But if I write the x values over here and the y values over here, and then I calculate the change, this goes up by 3, up by 1, up by 3, up by 3. And then over here it goes down by 3, down by 1, down by 3, down by 3. And remember that I'm doing the change in y, so I have -3, over the change in x, which is +3. And then on this one I have the change in y over the change in x. And again, this is -3 over +3. So all of these simplify to -1. So the answer is that the first one is a constant rate of change. So the first one is a constant rate of change. If you were to calculate the second one, it is not a constant rate of change. Okay, so we could also look at a graph to see if it's variable or constant rate of change. So you know that a constant rate of change makes a straight line, and a variable rate of change makes anything else. This one looks kind of like a parabola, perhaps. So this is a variable, and this is a constant rate of change. So a function is a linear function if and only if it has a constant rate of change. So we can go ahead and check if we think these are linear. So we can see here we have to check the changes in x over the changes in y. So if we look here, again, these do not have a constant change, so I have to check what is the change in y over the change in x. So they did 1 over 2 gave me a change of 1/2. Then a change in 0.5 over 1, so 0.5 over 1 was a change of 1/2. 1.5 over 3 is a change of 1/2, and 3 over 6 is a change of 1/2. So this does have a constant rate of change, and it is linear. So if we look at this one, and here's our calculations of the rate of change, you can see that this one is not linear. So go ahead and pause the video and determine whether or not you think that these two examples are linear or not. Okay, so if you were to look at this first one, hopefully you tried to calculate it, and from -2 to -1 is a change of 1, and from 1/4 to 1 is 1/4 over 1. And then if we look down here, we have 8 over 16, so that's going to be 8 over 1. So 1/4 over 1 and 8 over 1, that's clearly not going to be the same thing. So this one is not linear. Now here, if we look at this, and we're going to have a change of 0, a change of 0, a change of 0. So this is actually going to be a linear function. So the change is actually going to be 0. It's not going to have a slope. But since this is 0, no matter what this is, it's always going to be 0 over something else, making it linear. So remember, if you're given a verbal description of a function, you can determine whether the function is linear or nonlinear by making a table of those values and then examine the rate of change. So you could be given a table, you could be given a graph, or you could be given a verbal description. All right, so I'll give you a moment to go ahead and read the problem to yourself here. If you're not quite done, go ahead and pause the video. So hopefully right from the beginning, when you look at this, you can see that this is not going to be a constant rate of change. Hopefully you can see this is exponential, that it would be 512 times 1/2 to the x, because it's actually half each time. Whereas this one, you can see, is actually going down at a constant rate, and it's losing 40 per hour. So basically, based on the information, you can tell after making a chart that one is exponential and has a variable rate of change, and one is linear, and therefore it has a constant rate of change. All right, so at this point you should be able to try some practice problems. So you are going to go to page 350 in the book and try out some practice problems about rates of change.